fun. Okay, so we've got half an hour. So I'll post this for you after. We'll do filter. I'll show you, I'll provide you with useful examples. Okay? And I'll explain as I go. I won't provide any of the text that goes with it. But at least, because the examples I'm realizing are not super easy to understand. So we'll start with filter, because we already did filter. So, filter, again, will apply a filter to an array. So it's going to go through an existing array. In this case, my super tiny array, 1, 2, 3, will go 4, 5, 6, 7, 4, 1, 2, 2, 3, 4, 5, 6, 7. And what I'm going to do is I'm going to filter out odd numbers. This isn't one of your questions, right? Filtering out odd numbers? No. So we'll do that. So the syntax is as follows. I take the array I want to work with. I apply filter to it. And then I give it a block of code as a function. My function here can take upwards of 3 parameters. The element, the index, and the array of the element that we're dealing with in question each time over that block. So for example, element. The first time through, right, it runs this block of code for the first element. Then it runs this block of code for the second element. Then it runs this block of code on the third element, and fourth, and fifth, and sixth, etc. Element is the element itself. So the first time through the loop, element is 1. The second time through the loop, the element is 2. Okay, and just to make this more interesting, fourth time through the loop, 1, 2, 3, 4, element is 42. Right, okay, so we're good on that. Fourth time through the loop, index is 3. 0, 1, 2, 3. So it gives us 2 pieces of information. Awesome. So how do I filter? How do I decide what to keep and what to throw away? And again, we saw this earlier. Filter says, return true if you want to keep it, return false if you want to toss it. And I said, I want to keep every even number. How many even numbers do I have? 2. Okay. So keeping every even number, if element mod 2 equals 0, return true, else toss it. Get out of here. Okay? But we can make this even better by just saying return element mod 2 equals 0. Because what does this? This is either true or false. If it's true, that means it's even. If it's false, that means that it's odd. So this will return true on even numbers and false on odd numbers, and we get the exact same result. Okay? Which is why when you see in those little examples, they're so short. They're like 1 line. It's because they're leveraging this concept.
Can we go back?
Yep.
Just so I can see it that
Let me
way.
just copy this. So this and this are the same thing. I'll write this one, I'll give you this one, just because it might be a little bit easier for you to understand. And that's what I'm going for. I want you to understand filter. That's my focus. Okay? That's filter. And it returns a new array. So I end up with a new array of 34 and 42. Just the even numbers. If I want to flip it, I can just say false. If it's even, return false. Otherwise, return true. This will now keep the odd numbers. Okay. That's the same pattern for most of these array thingies. Most of these array methods. Let's take a look at, so it's called filter. Let's take a look at map. Map. Map is interesting. Map is kind of like filter, except it's kind of not like filter. Map, instead of filtering out elements and creating a new array, it creates a new array, but it creates a new array out of whatever we return. So, for example, let's copy this. Let's copy this junk. Let's paste it down here. Take this too. But now we're going to switch this to map. And all we're going to do is we're going to return true. That's it. That's all we're going to do. Let's run this and let's see what we get. True, 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 true. How many trues is this? 1, 2, 3, 4, 5, 6, 7. How many numbers do we have in our array originally?
7.
1, 2, 3, 4, 5, 6, 7. Interesting. I wonder if there's a connection there. There is. The idea behind map is that we might want to do something to each element in the array. For example, multiply it by 2. This will create a new array of each of these elements multiplied by 2. That's what map does. It allows us to take the value out, do something to it, and whatever we return becomes the new value there in the new array. It does not, again, map does not modify the original array. We end up with a new array, so now we have two arrays. We have the original, and we have a new one. So if I said, all those prices that we had in yesterday's example where I said go in and change a price, what if I said, ugh, you forgot to charge tax. Now go through all those prices and multiply them by 0.14 or 1.14 to add the tax. And you're like, okay, I'm going to write a for loop, I'm going to modify this, going to create a new array, going to do all that stuff, that same pattern that we were doing today. Map does it for you. Now, in your example, again, map follows the same pattern, element, index, array. Over here, we didn't use index and array, so we can just take that out. Over here, we don't use index and array, but you're going to need to. Because if I'm on element, if I need to get the previous element at the same time as I'm on this element, so I'm on an element here, but I also need to get the previous one. Well, I kind of need to know the index. The previous element is what?
Index minus 1.
Index minus 1. The next element is index plus 1. Of what? Now I can access, if I take all three, I've got all the information I need to play around with this thing, to get any element, to know where I am, to know what the element is. It's all there. It's all there. But in my super simple example, I don't need these. I'll leave them on just for your information. That's map. Map takes a block of code and returns a new array with your that applies whatever you need to each element in the array. You don't even have to modify the element. You could just make a new array of trues or falses or zeros or ones or tens. Doesn't matter. Whatever you return is what it's going to put. Map.
In the question, the answer that you're looking for is multiply in the parentheses. There's a bracket 1, 2, 4. Can I put that into like my array? Put a variable to it. Otherwise, I don't know how to.
Yeah, of course.
Okay. So I don't have to do this.
You don't have to.
Can I? Like, how can I do this? All this way again.
Well, then you would need to put map inside of a function called multiply that you write.
Okay.
Okay. And sort. Again, a lot of these you won't use, especially in this course. And that's not why I'm teaching you these. That's not why we're exploring this stuff. We're exploring this stuff because Millie went online and found documentation or information about replace string. How dare you? Right? She's going in and picking up something that we haven't taught, we haven't learned, and she's like, oh, this looks like it might be useful for swapping characters? Yeah. Was it? No, not really. But hey, maybe you're going to find one day, even in this course, that this, oh, I can just map this. This would be so easy if I just did map. Oh, this would be so easy if I just used join, if I just used sort, if I just did this or if I just did that. And it is, right? I'm trying to expand. It's one, documentation is important, and two, expand. We could just sit here and solve more problems, but it's more interesting if we solve problems with tools that we're just learning. Sort. Let's sort this. So sort's a little bit different because it doesn't return a new array. Yeah, it does, sorry. It does return a new array. It doesn't sort the original one. It creates a new array sorted. Let's see how sort works. So sort has two different versions. It has a default. I can just call sort. Let's see how it sorts it.
You won't see a difference.
Oh,
All
right.
your numbers are sorted.
Because all my numbers are sorted. Let's make something that's not sorted, okay? Cool. So now, why did it sort it like that? 1, 1, 21, 32, 34, 4. It's based on the first digit. Is that how I want to sort this thing? What if I want, like, if my intention was to sort this numerically, ascending, that's not the right way. And so, this is the default action for sort. It sorts it based on how these characters, because it turns them into strings, how these strings appear in our codes, our Unicode thing. Binary representation. Okay? Turns them to strings and then sorts them based on that. So, because it isn't sorted properly, I need to tell it how to sort it. And I need to tell it by using a function. I get to pass it a block of code. And what I'm returning, it provides me with two elements. You can call it A, B, you can call it ELE1, ELE2. And the idea is, if I tell it, if it just gave me two numbers, 1 and 21, and I said they are in the correct order, or they are not in the correct order. If I told it how to just sort two elements, it can figure out how to sort the whole thing for me. It's like, oh, I know how he wants to compare these two. I'll just apply that same logic to all of them. That's what we have to tell it. So it's going to just give us two elements, the first two elements. Doesn't really matter. And all we have to do is return, let me double check this, JavaScript sorts. Oh, so here's something interesting. The sort method sorts the elements of an array in place. That means does not create a new array. That means it modifies the original array. So, return value. Note the sorted array. Return value is the sorted array. Note the array is sorted in place and no copy is made. So you're destroying your original copy, which is fine as long as you know that.
So then you don't need to create a new array, you just use my array.
Yeah. I don't need to create this new array, but it does return an array as well, but my array is, yeah. Yeah. So here's how it works. We need to give it a compare function. Specifies the function that defines the sort order. If omitted, which I did at first, I omitted it, they're converted to strings, then sorted according to each character's Unicode code point value. Don't need to worry about that. It's how do we compare two strings? Which string comes first? Right? If you were to do greater or lesser than on strings, it'll tell you true or false depending which string comes first. We need to return if compare function returns less than 0, A comes first, B comes second. So A, B, which is exactly the order that we get it in. So if it returns less than 0, don't change the order. If it returns 0, remain unchanged with respect to order, but sorted with respect to all different elements. Greater than 0, B, lower than, so greater than 0, flip them. Less than 0, keep them. 0, keep them. Less than 0, flip them. Or greater than 0, flip them. So we need to return some number. A number. You can always do an if statement. If blah, return -1, else return +1. So you can do that. In our case, what if we did A minus B? What do we get? 1 minus 21. We get a minus number. Is that what we would want? Negative 20. Less than 0 means what? Stays. So that's good.
A is before.
So all we need to say is A minus B. That means B is bigger than A, right? If A minus B returns a negative number, that means B is bigger than A, and B should be on the right, and A should be on the left. And that means these two are correctly sorted. Now let's take that same logic and just apply it to everything, and we're done. Let's just try this. Oh yeah, we're console log my array. I taught it how, in a really, really simple manner, how to deal with two elements. And now that it knows how to deal with those two elements, It knows how to deal with the whole thing. Maybe I don't want them sorted like this. Maybe I want them sorted in a different way. Fine. The idea here is that my block of code, it can be as complex as it needs to be, as long as at the end I'm returning minus, 0, or plus. That's all that matters. That's all that matters. It can, if I need to do some sort of super complicated stuff to figure out how these should be sorted, but once I figure it out, I'm returning keep it, or flip it. It can figure out the rest. So the idea behind passing in these blocks of code is exactly that. We can be super complicated, but at the end of the day, we're telling filter, we're telling map, we're telling sort, we're telling for each, we're telling whatever. Here's the return. Do your thing. Okay?
How would you do it a different way? Like, how would you use sort in another way other than?
Well, you're going to use sort to sort an array of strings.
But like when I do return A minus B, that's the only one that seems to do anything. Like I tried greater than, less than, equal, plus. I don't see. Looks.
Well, the thing is, I feel like you're just throwing things at it. You're just trying stuff. And it needs to be like A minus B, what happens to B minus A? It'll flip it around, right? If I did B minus A here, what do I get?
Okay.
I get an array that's sorted in reverse. Because I'm essentially saying, well now, B minus A, 21 minus 1 is plus 20. That means if it's plus, flip them. So I'm saying these two that you're comparing are in the wrong order, flip them. And it says, okay, I'll take that logic and I'll apply it to the whole thing, and boom, it sorts the whole thing. At the end of the day, it has to be a number.
I think Brian can use it to one check. So after 77, there's one. It doesn't just check, well, not the answer.
No, it's not just taking these two, then these two,
Yeah.
then these two.
Goes through everything.
Under the hood, well, not only that, it's not just doing these, then these, then these. It's doing multiple passes. It's doing multiple things, right? It's going back. Oh, I moved this over here. You gotta go move that over there. Oh shit, one. Where do you go? Oh, you go like way over here, right? It's doing a lot of different stuff. But the important thing is we don't care, right? Under the hood, abstracted away from us, I don't care how it's working. It's doing it. And the nice thing is, I hardly have to do any work. The important thing to know is that we need to know how it's working. Why is it working? We can't just say, oh hey, I changed the minus to a plus and boom, I got it. I don't understand why, but I got it. That doesn't help us, right? Using an arrow function, using this arrow here, without understanding why, that is not helping you. That is hurting you. Okay, now there's just literally magic happening. This magic is intentional. We know what it does. We know how to use it. I don't know how my car engine works. I know it takes oil, I know it takes gas, I know I put the key in and turn it on, I do all those things. I know how to use it. I don't know how to fix it or the internals, but I don't need to. It's abstracted away, right? If it breaks down, I'm screwed. But again, if this breaks down, you're kind of screwed too. It wouldn't break down. It doesn't just stop working. What's that?
I said sorry. I asked.
No.
Like it was abstract. I just thought that try something.
No, yeah. Yeah.
What would this be? So what is the arrow mean?
I'm sorry, what would the arrow be?
Arrow, yeah.
I don't want to get into that today. It's time to go home. That's a whole